guys, Ionic naming video number 3, and we're going to use something called a polyatomic ion. So, Mr. Demetrius, what's a polyatomic ion?
Polyatoms, right?
Polyatoms.
Well,
Poly means what? More than one.
More than
right?
one. So anytime you have a molecule, an entire molecule made of more than one atom, has an overall charge, it's called a polyatomic ion.
And it's an ion, meaning it has a charge. So what's an example of one polyatomic ion?
This will be something called chlorate, ClO3 minus. This entire molecule has a charge of a -1.
Okay, so that's chlorate. Now let's take a note. As you look inside of your notes packet, you're going to notice there's a list of most common polyatomic ions. And there's actually, at some point we might ask you to memorize it, I don't know or not. But if that's the case, there's kind of some patterns that you may not have noticed. What do you notice about the patterns? That this is called chlorate. What if you write chlorate next to it or something like that? So that's chlorate, but there's also one called chlorite. So ite has, here's my rule, has one less oxygen. Eights always have oxygens, and the ites with one less oxygen, and they keep the same charge. So chlorite would be
ClO2 minus.
So my recommendation, if you're trying to learn the polyatomic ions, is learn the 8 ones, they're the common ones, and then the ites are always one less.
Yeah, group them together. It makes it a lot easier.
It saves you don't have to memorize nearly as much. Now, today though, our main focus is we want to learn how to write the formulas and the names of these ionic compounds that contain these polyions.
And before you get all freaked out, they're exactly the same thing we've done in the previous videos. The only thing is that instead of having a single atom with a charge, we're going to have multiple atoms with a charge. It's not that much harder.
All right, so Mr. Demetrius, why don't you give us an example?
So let's try with this one. Magnesium nitrate.
All right, so magnesium, we've done this before. Magnesium, second column, Mg, +2, right? You write the symbol with the charge. Got that? Now nitrate. We grab our sheet right here, right? We look up nitrate and we write the formula NO3, -1. Now, do you notice? We've got a 2 positive and a -1 charge. I need to have 2 nitrates. So watch what Mr. Demetrius does.
So I always think of it this way, and it may be silly, but we don't care what's underneath here. All we care about is the charge. See, we have a 2+ here and a -1 here.
We just need another minus.
We need another minus. It just so happens these minus come packaged in NO3 format. So really what we're doing is we're looking at these two right here, this minus, and you see how these two add up to, wait for it, -2
and +2.
And this is +2.
Now, when you write out the formula, you're going to have to do some parentheses. So you've got 1 magnesium. So what are you going to? How are you
I'm
going to
erase this right here. So we're going to write 1 magnesium here, but then I know I have 2 of the NO3s.
So yes. So
we're going to
watch
put
this.
parentheses, and then we're going to put the NO3 in the middle, and then we're going to tell how many of those NO3s we have. Now, don't we have 2 of these NO3s we need to add in here?
Yes.
So we're going to put it on the side. Now, mistakes sometimes students make are like, oh yeah, let's do like we do in math, and let's just play this out and make it N2O6. That is not the same thing.
No.
Anytime you have more than one ion,
You parentheses.
you've got to parenthesize
That's it. That's it.
And this is our final answer.
So let's do another example.
So let's go crazy on everything here. Let's go ammonium, and let's do carbonate.
Ammonium carbonate. Now, ammonium, you're going to say, wait a second, the cation, that's not one of the elements on the periodic table, ammonium. But if you look at your polyion list, this is actually the only common positively charged polyatomic ion. So if you notice, it's NH4, +1.
Plus.
Okay, and carbonate, again, look at the table here, it has an 8 ending, so it's going to be CO3, 2-. Now again, if you cover these up, right, we got +1, -2, what do I need? Another NH4, so I'm going to write another NH4, and so I need 2 ammoniums and 1 carbonate. So watch how Mr. D writes this out.
I have to have 2 of these, and then remember, it's a polyatomic ion. I cannot just multiply this out. I'm going to put a parentheses around the outside, put a 2 next to it, and don't we only have 1 of the CO3s?
Yeah.
So there's no need to put a parentheses around it. I mean,
You can if you want.
you can go like this, but that's bananas.
Yeah.
There's
So-
no need to do that. In fact, we frown on that.
Yes, yeah, that kind of looks cheesy.
It does look cheesy. And
It's,
I'm going to
bad. It's bad form.
Bad
Chemistry
form.
land. Yeah.
That's what you end up with.
So let's do another example.
All right, so let's try this one. Again, I'm not telling you there's going to be a Roman numeral. There's going to be a Roman numeral. So let's go lead. Let's go crazy with the Roman numerals. Lead 4 hydroxide. And this is one that people actually make mistakes on. Because they get a little bit confident.
You'll see. So lead, we know that symbol is Pb. And the Roman numeral tells us the charge.
We love that it tells us
+4. Yep. Hydroxide is an interesting one. It's from your table here. minus 1.
Yep.
So how many OHs do I need?
Again, if we just look at this like
Four
this,
and four.
yeah, plus 4, when we need 4 minuses.
I need 4 of them.
Now, just for those of you who are visual learners, couldn't I go like this?
Yeah.
But again,
So it's PB, OH, 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 OH.
Now-
Well, we don't write PB, OH, 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 OH. We write,
we're gonna use parentheses again. So I'm gonna write the PB here, and I'm gonna put parentheses, OH, in parentheses, 4, because
and
there's
that's
4
the
of them.
correct answer, but here's a mistake we almost always see students make. Why don't you write out the answer that we often see?
We see
Students
this.
often write this, but you see, real, this means 4 O's and 4 H's. This means 1 O and 4 H's, but we've got 4 O's and 4 H's. So you have to put the parentheses there.
The best way to look at it is if you ever have more than one of these polyatomic ions, you have to use a parentheses. You have to. We don't want to see that. That makes us very sad.
All right, so folks, that's how we do this, right? We got one more to do with polyatomic ions. That's coming up next.
We'll see you next